anything?
Nothing.
Oh, fine.
I
I'll
want
just
to
move
say
on.
hello to all. That's it. Nothing but
Oh,
hello.
okay, fine. Yeah. Great, guys. Moving on to this. So the last time when I just working on this Plaxis and it suddenly got closed it. Yeah, this pretty much will happen it when your machine is not responding properly, or if your cache memory is too high, or if your RAM is not sufficient, or if there is any antivirus in your machine, or else if your machine is too weak. I mean, if it is loaded with so many applications, and if you are not restarting the machine for a longer periods of a time, or if there is any Windows updates happens and all. So in this particular point of times, actually, there is a high possibility of coming an errors like this. So on that particular cases, though you restart your machine, whatever you do, once when you reopen the Plaxis, it will ask you, do you like to click on this recover the crashed project? That means you're working on this particular project, but it's suddenly that you have just closed it and now you would like to save it, right? So when you just click on this recover the project actually. So wherever you left from there, actually it is going to consider the project again. Okay. So the last time that we have seen something and other that when we are just trying to visualize the mesh, right? So now click on this view mesh. Now you can see the mesh of the server here. Okay. So here, guys, please be remember that what is a mesh? That is where actually that we were just going to come into this. So in the very first session that you guys have learned that when we are discussing about the finite element analysis, you got to know converting that infinite number to a finite number and giving a proper shape to it. Either the shape is a text shape or a quad shape, and that shape is nothing but we are calling it as an element, right? So this is a soil, and this particular soil I'm dividing into a small intervals, a small pieces, you can say that, and I'm going to study the behavior of an individual piece. So the main foundation load actually it is coming it over here, and if you would like to zoom, it is just a control and scroller. Okay, the main load it is coming over here. That's why I need a good mesh over there. And the effect of this will not be that much over here. That's why I can just create a rough mesh over here and all. So this way, actually, the Plaxis will take care about this. So when you're just trying to perform this particular mesh quality, actually it is not required for you when you're learning for a Plaxis. But in general, I can just tell you that you have to follow a few things called as an aspect ratio or deviation, TED collapse. These are the minimum mesh quality parameters that you just need to follow this. Along with that, there are some other parameters also like a minimum length and maximum length also that also you just need to maintain that. And warpage is the one more important quality parameter. So the quality parameters are like aspect ratio, chord length, warpage, chord deviation, and minimum length, the maximum length. So these are some 5, 6 parameters that you need to verify that. So each and every time that you just need to check these particular quality parameters and along with the TET collapse. Sorry, as this is a tetra mesh, actually you need to be checked with the TET collapse also. So this is the minimum parameters that you need to check it. So when I'm just checking with this, if the quality is not good, then again I have to go back and redo the mesh. If you are using Abacus as a solver or ANSYS as a solver or any other FEA solver also. But in Plaxis that you have a freedom that Plaxis will take care about your mesh quality and then it will do the mesh accordingly. Now see this, the number of elements in your concentrated zone, it is a less, and the number of elements that is coming in the outside the concentrated zone is more. So this is where actually that really will notice you that, oh, okay, this is where actually I need to calculate more number of equations. So that's why I have to create these particular things. Okay. Now, when you just go for this particular mesh in detail, so when you just go for the mesh, here you have something called as an materials. If you just uncheck this, whatever the color of the material that you applied it will not show. But if you just make sure that it will show that. And in few cases, when you go for the mesh, actually, element contours. So though when you are trying to visualize this particular mesh, there won't be any mesh over here. So you have to be. careful. Don't worry about that. There is something wrong and all. You might be get panic in these particular situations. Don't make all those things. Simply go to the mesh and check whether the mesh contours is on or not. Okay. And if you want, go to the mesh and click on the cluster borders also. So what is the soil cluster borders also? It can show you that. So this way you can able to separate the structural elements to the soil elements in the visualization if you would like to capture some good image. So this will helps you on that particular things and all. Okay, soil clusters also you can able to go for this. And element numbers actually, if you just switch on this particular element numbers, this is where it is going to create this. This is an element 1, 2, 3, 4, 5, 6, 7. And then this is an 8, 9, 10, 11, 12, 13, 14. And this is how actually it will keep creating these particular element numbers and all. So there are like a huge number of an element numbers. So each element is having assigned with a number. Randomly it will assign it. But this is in between of a 1 to the maximum element number that we have it. Okay. So but if you would like to analyze what is happening on this mid element like 277 or 284, in visualization, you have an option to pick this two elements and then you can able to check the stresses. So but someone if asking the element numbers, please be remember that there is an option called as an element numbers. Again, in the mesh, if you just go for this, material set numbers also. So I have a material 1, 2, 3, 4, 5, 6. So 6 materials I have it. So which material, which layer it is occupied, it will also display. Here I have only a one material, so that's why it's always show it as a one. This is all just for your, I mean to say for your presentation purpose, it would be helpful for you a lot actually. And then going for the structural material set numbers and all. I don't have any structures over here. That's the reason it is blocked, hide it. So, and if you would like to go for a soil cluster, you just put the cluster numbers also. This is also only one particular soil layer I have it. So it's also coming up with only a one particular number and all. So if you would like to grouping the numbers, you can able to possible that. And the input points also, you can just able to see that. If there are any particular set of points that has been added, in that particular cases, you can able to see those particular input points also. Okay. So this is where it is all good. It is all good. Now you could able to capture this particular element numbers and all. If you just look into this particular element numbers, there is an option. Like if you just say that there's some 288 element, I have just seen this. So this 288 element will have a three different nodes. Nodes. Please be remember the new terminology. It is coming is called as a nodes. So 1, 2, 3. These are the three nodes it is having it. So these three nodes is what actually the Gauss coordinate equations are going to be calculated behind the finite element analysis. So here it will calculate, here it will calculate, here it will calculate. Based upon these two, it is going to calculate the midpoints and then it is going to show the information. Okay. Now, this is an element, right? So this is what actually you got the element. Let me go back. Okay, let me go back to this. And this is where actually we were discussing, right? So we will just continue in the same way. Now, there is an element. This is what is actually the element that we were just calling it. Yeah. So if we just say this is what is an element that you are calling it. This is what is an element that you are just calling it. Okay. Now, to this particular element, if I just wanted to do something, what exactly I can able to do this? Okay, so when you just take this as an element and the Plaxis supports only the tet elements actually. Oh, sorry, I'm using a wrong keyboard. That's why it's coming like this. Yeah. Plaxis is using only the tet elements actually. Here, Plaxis uses is only the tet elements. That's why we can see these particular elements and all. If we just go for this particular elements, these end points that we are going to call it as a nodes actually. So we can say this is a node 1. Please be remember this. This is a very basic thing, guys. So we have to be very careful about and understanding this. Please stop me if you didn't understand anywhere, because this is the same process that we are going to follow for 2D and as well as 3D as well. So this is a node 2 and this is the node 3. Okay. So you have something, Plaxis supports only the tet elements, and there you have like a node 1 and node 2 and node 3. So when you just go for this particular things, you have something called as 6 noded, and then the 15 noded elements is what actually you can see that in the file properties, that if you are just going for this project properties, if you are just going there, actually, if you just go for okay. Why this is as the page is breaking. Okay, yeah. So this is the project properties. When you just go for this project properties, here you have something called as 6 noded and 15 noded. Yeah, when you just go back to the soil and file project properties, if you just go here and to the model, if you just go, you have something called as 5 noded and 6 noded, 6 noded and 15 noded actually. Okay. So what is happening here is like, what is a 6 noded and what is a 15 noded, that you need to understand it. So normally it is always recommendable to go with the 15 noded as a solution, because this is a higher order differential equation solving. So what do you mean by higher order, and what is the 6 noded and what is this? When I just look into the element wise, this is a one element that I got it, where this I have it as a node 1, node 3, node 2, node 2, node 3. These are the 3 different nodes I have it. Okay. But when it just go in deep into this particular element, if you just go in deep into this particular element, what will happen here, these particular set element is divided into your multiple points. So those points are something like, yeah, you can just use this as your points. You can use this. Okay. So here, this is your point. Yeah, this is a 1 point. And then again, Flaxus is going to calculate the base points. This is a 1 point. This is the second point. And this is the third point. And it is going to calculate the points like this again. This is the fourth point. This is the fifth point. And this is the sixth point. So what it will tries to do, Flaxus always try to solve if you are putting up like a 6 noded elements. In the 6 noded element, actually, the Flaxus will try to understand this in this way. So what are those particular 6 nodes? The base nodes are like this, and this node 1, node 2, node 3. And the midpoint between these two nodes will consider as another point, and that's why it is calling it as a 6 noded elements. So what we call this particular things as a 6 noded element. So we call this as a 6 noded element. How it is considering it also, I will slowly show you in the Plaxis itself. This is called as a 6 noded element. And now the moment that when you just go here again, if it is like a 15 noded element, there is a one more option, right, that we have seen. It is called as a 15 noded element. if you just look into this particular 15 noded element, actually how this will respond is in this way. So now these are the base nodes that we already know. This is like a node 1, and this is like a node 2. We know this. And this is a node 3. And then we have like node 4. Please be take care of these nodes because this is very, very important. Node 5 and node 6. These are the default nodes that we have it. Okay. And along with this particular node, it's going to calculate the values in between this also. So that means it will calculate 1 over here. It will calculate a 1 over here. And then it will calculate a 1 more over here. So for look wise, it is like this. So you can say this is a way, and you can say this is somehow in this a little bit. Yeah, this is how actually it will help you to calculate this particular things. Now you have like a node 1, node 2, node 3, 4, 5, 6, 7, 8, 9. And in the similar way, after forming these particular elements internally, as you requested for the 14 noded elements, again, it will try to simplify your solution. So it will search a midpoint between these two again. And again, it will form a one more midpoint between these two again. And again, it will try to form a one more midpoint over here. And this is where again, it will form a one more midpoint. And here it will try to form another midpoint, and then here also another midpoint. Now you see that on a line that I have like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that's why we call it as a 15 noded element. So this particular thing, we are going to call it as a 15 noded element. It is not 115, it is just a 15. Okay, so that's why we're calling it this as a 15 noded elements. So when you just wanted to do this one, I suggest you, yeah, you're going here, right? You just close this one, go to the mesh module itself. Okay. Go to the mesh module itself. Now here, instead of view the mesh, generate the mesh or view the mesh, you can just select points for curves actually. So just click on the select point for curves. When the moment when you just click on the select point for curves actually. So now here it will be coming up like this. Now I will be just zooming up to a one particular element here. Now you see this, how the dots are calculating it over here and there with a small little distance. You got to know. So the actual thing is like, if the actual geometry it is there, perfect 100% quality that if you maintained it, then actually it should come onto this, or else slightly it will move here or slightly it will move inner to this. So it will happen it like this and all. So that's why this is a 15 noded element. Now you can see this guys, there are something called like a 15 nodes. It is getting capturing it over here for one particular element. If you see this is what it is happening. You just capture this particular and concentrate on one particular element. Side by side also the elements are there. Please be remember that too as well. Okay, for one particular element, if you just see this one, this is how actually it will capture it. Now let's do one more thing. Now I'm just closing this one. And coming back here, go to the soil module, file, project properties, and to the model, instead of 15 noded, I will be connecting to the 6 noded elements and just give OK. Now coming to the mesh, it will ask you to generate the mesh. So just give OK. After the mesh is done, you just try to visualize the mesh. Now you see this, the mesh and all, it won't change because the element size, everything is same. And previously also, if you would like to go to the mesh and switch on this element numbers, you can see similar to that of an element numbers 277 to 84, and randomly it will be changing sometimes. Okay. So in this particular cases, now I'm just going for select the point clouds. And now this is where like the 6 noded element that I have selected it, right? So for the 6 noded element that if I just go and now zooming up to this. Okay, maybe I can just switch off the element numbers so that we can take the unique picture. Now, if you just see this particular thing for a particular element that if you would like to capture the image. Now see this one, 1, 2, 3, 4, 5, 6, only those things. Okay, but you have something called as a midpoint. So 1, 2, 3, 4, 5, 6. But you have one more 3 points. So what are those particular 3 points? If I selected it as a 16 noded, but again that I could able to see some points internally. So what are those particular points? This is what the next question now come in picture. So now when I just look into this particular, what are the other points that it is showing here? So if I just look into this one, now I just understood this. These points are called as a Gauss coordinates. So normally what we call these particular things are called as a Gauss coordinates. Even in this or this actually that we will be having either one between these two, between these two, and between these two, between these two, or between these two. Yeah. So like this, it is going to these two, these two, and these two maximum will try to create one particular points based upon the shape of it. If it is a perfect shape, all the points will come at the middle, but the shape is slightly deviating it. So that's why the points will slightly more. So those particular points, we call it as a stress points. What you say? So these particular points, if something is coming in between, so these particular points, actually, we call it as a stress points, or these points are also can be called it as a stress points. So we can just call them as.
Sir, will you please repeat between cross point and stress point?
Yeah.
Or both are stress points only?
Both are stress points.
Okay.
How it is going to understand the element and create is what is the cross cycle. That's. So this is nothing but your stress points. And whereas if you just say these are nothing but your
These are the
nodes.
nodes. These are different.
So the one that is coming onto the line is called as a nodes, and the one that is coming inside it is called as a stress points.
So these are the vulnerable points when you make an analysis you should worry about.
It is not a vulnerable points. This everything is considerable one only. When you are doing the mesh, if you just choose this as a 6 noded element, then you're going to get the 6 noded element meshes is like this. And when you just choose the 15 noded element, it is like this. Yeah. Why this is and how 15 noded is more good when compared with the some 6 noded element is what that we need to understand this. Yeah. Coming on this point, I will explain you that. Okay, so why it is very much Why this is very much important, when you're just calculating this, the Newton-Raphson method, it follows it, or we can say it is called as a quasi-Newton method in FEA. Anyways, I'm not going to teach you the complete theory of it. Don't worry, but I will just give you a glimpse about that. What is the Newton-Raphson method and how it is solving when we are solving for any kind of a problem. Okay, but before that, like how actually the mesh is happening, that we will see that. So I just wanted to know how many of you know how to calculate the velocity. Can you give me an example how to calculate the velocity using a differential equations? Can I
The
call this as
distance
a
upon
dx by
time,
dt?
dx by dt.
Okay, so this is one of the differential equations I'm solving it, where the velocity I would like to calculate it as dx by dt. Now, okay, why the t got small?
With direction.
Okay. Now the velocity, this is there. So for this, actually what I call this, I'm going to call it as a first order differential equations. I'm going to call this as a first order differential equations. Okay. Now there is something beyond that I need to go. That is where something I'm calling it as a acceleration. So how do you
Acceleration.
solve the acceleration?
Derivative of this.
Again, I need
Dx
to
by dt.
do the derivative. So now I can say
T
that
square
as
x
like
by dt square.
d square x by dt square. Okay, so if you are confused about that later. Okay, so d square x by dt square. So this kind of differential equations, I'm going to call this as a second order differential
Differential
equations,
equation.
or DF, you can say DF. Okay, second, okay, don't be get confused again after DFE. A few days again will come back. Yeah, this is the second order equations, I can say that. When I'm just solving it as a dx by dt, I'm calling it as a first order. When I'm calling it for the acceleration, it is d square x by dt square, second order. So if you would like to solve any kind of a problem, which one you prefer it as more accurate model? Velocity or acceleration is more accurate?
Depends on the situation.
If I really wanted to give some good solution.
Some normal cases, acceleration, deceleration will be there, except the case of constant velocity.
Okay, I'll just come up like this actually. So what I do, I have something, uh, maybe I'm just traveling from this is point A and I'm just traveling to some point B. Okay, so let's say I'm just traveling to from this particular end and to this particular end, I'm just traveling it. So now in between that, let's say this, I can say it as one of the best places I know. It's been for a long time that I've driven. Okay, from Hyderabad, and people has to come to Chennai. So from Hyderabad to Chennai, if I just wanted to come, what are all the basic points that I need to touch is something like I can just go and make this particular point into break 1. And again, I can just go put this as a break 2. And again, I just go and put this as a break 3. So three different breaks that I'm going it when I just wanted to see when I'm moving it from Hyderabad to Chennai, or you can say that you are moving from Chennai to Hyderabad. Both the ways arrows are fine. Okay. So in this particular way that I have some three different pointers to stop in between that. So the three pointers to stop in between that is something like, you can say this one is Ongole, and the second thing you can say it is like Nellore, and the third one you can say something like Red Hills. Okay, so I'm not specific to the any names. Feel free to change your names that if you want to. These are the common places I used to stop. Okay. Now, when I just go for this from Hyderabad to Ongole, it says that like I took some particular time actually. So the time I took here is something around like 3.5 hours. And now here I'm just putting it something here is something like Ongole to Nellore. I just kept something around 1.5 hours. And then again from I just wanted to go from Nellore to Red Hills. There again, you took something like 2.5 hours over there. And from there, actually, the Red Hills that if you would like to go inside to a Chennai, so that will be taking some 1.5 hours. I can say plus how to put an infinite number, I don't know. That depends upon the traffic conditions again. So you can just consider that. So 1.5 hours to just to touch the Chennai border. Yeah. Now, this might be a question that you got it, a general physics question, a very layman terminologist. Now, from Hyderabad to Ongole, that you took 3.5 hours. Is it really because of the? I mean to say, okay. Now, yeah, you can just mark this, not 3.5 hours. You can just mark this as a 6 hours. Yeah. So now you can just tell me that from Hyderabad to Ongole, I just took like 6 hours of a time. Is it really because of the kilometers, or it is because of something else actually? If it is because of something else, or if it is just because of a kilometers, or how it is going. So if you calculate this, the distance traveled here is something like what I have here. I have something around 200 kilometers or 200, no? Might be more than that actually, some 230 kilometers. Yeah. So if you have something like a 230 kilometers over here, and you have something called as a time also. Now, if you just go and do this 230, and you're doing your calculations over here. So for this 230 divided by 6 hours that you are doing it. So what is that thing that you're going to get? Can someone please calculate and let me know? 230 divided by 6 is something around 38.33. 38.33. So this is what is the actual velocity that I got it. So this is what is actually the velocity I got it. I can say it is like kilometer per hour. So I could able to go like a 38.3 kilometers per hour. If I do the accelerations for this, so what I need to do, if I just want to know the accelerations for this is just d square x by dt square as the formula that you got it. So if I just wanted to know the accelerations for this, what I need to do, I just wanted to know the accelerations for this, what I need to do. So this is what is actually that you are going to get is something like 3.19. So we can just simply mark it as like 3.2. 3.2 kilometer per hour square or something like this. Yeah. So now this gives you only the velocity that when I just go for single differential equations, that's give me a velocity, which is a very straightforward number, easy to understand, easy to make the decisions. Everything is fine. But when I just go derivate it again, so this is where actually d square x is nothing but your velocity divided by your time square. That gives you an acceleration. That is nothing but your meter per second square or kilometer per hour square here. So this particular acceleration will let you know that whether you are driving at a constant speed or like you have a multiple intervals of a time over there. So this helps you to analyze the information in more detail. In more detail, that is where like you are multiplying the time and then you are dividing that your velocity. So that's where like it will helps you to go and detail all this particular thing. And moreover, this acceleration helps you to reduce your number of hours. That is where like a double digit number that you are projecting it is always can be showed in a 2-digit number. That's where like derivation it is happening it. So it is with the respect to the time, what is the deviation it is happening it, if you would like to show this. Now, when I just coming to a finite element analysis, all the times that I'm going to solve my equations, all my governing equations with 16 by 16 matrix, or sometimes it is 32 by 32 matrix. If you would like to solve a 32 by 32 matrix between the two different matrices, how much time it will take? Approximately, can I say 1 hour, 2 hours, 3 hours? And sometimes it is infinite. And this kind of 32 matrices, it has to solve in for each and every node that you selected. Each and every node that you selected, it is going to calculate the governing differential equations at that particular intervals. So if it has to be get solved it over there, and if you would like to get the more and more accurate results, it is always suggestible to go over there, go over this particular second order differential equations. So that gives you a better clarity on the solutions that it is getting there. So now, if you would like to solve this one, it is going to solve only a 6 equations and 3 Gauss coordinates. If it is like this, 9 coordinates and 3 Gauss coordinates, completely of like 12 plus 3, it is going to solve completely around like 15, it need to solve it. So which is a time taking process, but it is a more accurate process. If you are going with a 3-dimensional plaxis, suggested to go with 6-noded. There you have like a 3-noded element also. When you're coming to the plaxis 3D, I will teach you that. But for plaxis 2D, it is always suggested to go with 15-noded element for calculating the better matrices in a lesser intervals of a time. For calculating the better matrices in a lesser intervals of a time. This is how actually that you can able to calculate this particular things. And this is the reason that you need to stick on to a 15 noded elements. Next, you have to do me work for me saying that what is the difference that you see in the results when you are trying to solve any kind of a problem? What is the difference that you see in your results for a for I mean 6 noded elements and 15 noded elements? What is the key difference that you are able to see that particular things that you need to highlight it over here? So going back to here, so this is where like meshing. 6 noded and 15 noded. Six noded and 15 noded elements that we were using it, right? So now here you have to please run any analysis with the same element and update the results. So you can start can start putting your comments in the discussions and then we can slowly just do this particular things and all. Okay. So this is what is actually that we were just trying to solve this. So this is where you can just capture this particular image as well. So for your reference, it could be there. Okay. Now, a few things that I have used, one called as a Newton-Raphson method or like a quasi-Newton method or a Gauss coordinates or something like this. So slowly I'll come back to those particular things also when we are just working on to the type of the analysis. Now for today problem that I'm just solving it here. Now going back to the soil, so select the project properties. In the model, I'm going to select it as a 15 noded elements. Now after this, whenever this particular star symbol it is there, it is indicating that your remesh is required always. So click on this and click on the generate mesh. And instead of coarse, if you would like to go for a very coarse mesh also, you can do that. And try out all the things, Still meshing is not yet completed. I will just slowly come up with you with multiple options as well. Now going to the flow options, this is where actually the global water level it will display it. When you are just selecting for the borehole, that particular water level it will display over here. So you can just see this. Now moving on to the stage constructions over here. Now into this particular staged construction, this is a very important step that you need to be very careful. Very careful that you need to be there. So if you just look over here, this is the concept that what you are just trying to solve this, no? For the machine and all. Okay, this is the complete meshing that we were discussing, right? So after the meshing that you have some kind thing called as a flow conditions that we have noted there. But this is a one more topic is called as a staged constructions that is very important. So what exactly this particular staged constructions will do is like, so in the stage construction, so in the staged construction, it will follow the exact steps that which you have to follow on your site construction. So you have to be very careful in site how the work is happening it in the same way that you have to reflect it over here also. Yeah, let's come and we will see one small example and then we will come back to this. Now to the staged construction. Now when I just go for the staged construction, these are all in the deactivated mode. If you see that line load is not activated and only the soils is getting unactivated over there. Okay. So now in this particular case, this is where I'm going to my site and where I have only the land over there. Okay. Now only the land it is there. So you have to do that. So initial phase is what automatically it will be created by the software. That's where like the initial thing. And then it is going to calculate the KO procedure. So then it is going to calculate the KO procedure. So the KO procedure will is like direct generation of an initial effective stresses, core pressures, and the state parameters, equilibrium not guaranteed. So when your soil is at an equilibrium conditions, it is going to generate an initial effective pressure actually. So that means there is a soil, but in reality, if there is a soil available over there, by its own, because of the gravity, there is some kind of a pressure. I'm saying that not only because of the gravity, because of the self weight also, there is some kind of a pressure it is there. So I would like to include those particular parameters over there. That's the reason I can just choose this as a KO procedure. Apart from this, there is a field stress and gravity loading it is there. So first concentrate only on the KO procedure. So if you just choose it as a KO procedure And the remaining things as a loading type, you can just leave it to a staged construction only. So stage construction. So it says that phase construction or for the stage construction. So this is how many stages that you are going to do that, like those kind of things it will be do that. Slowly we'll come to that. Now we just remember the thing called sigma m weight is mentioning it as a 1. Please remember this. I'm going to ask you the question on this. Sigma m weight is mentioning it as a 1. And pore pressure calculation type that we were just choosing it as a pneumatic pore pressure conditions. So the pneumatic, when
Can
you
you
just
please,
select it as, yep, sorry,
can
sorry.
you please repeat the KO procedures? I lost my connection.
Okay. So the KO procedures are nothing but your Jackie's formula it will follow that. Hope you know about the Jackie's formula, right? 1 minus sine phi.
Actually, I have heard it, but I am not recalling it right now.
Okay, fine. So it will follow the same formula to calculate the KO procedure. So this particular KO procedure will calculate the pressure inside the soil. If you have an initially soil and a site also, if you just go, because of its self weight of the soil, there is some an internal pressure already there in the soil, right? So I want to calculate that particular pressure first. I want to calculate that particular pressure first. To calculate that particular pressure, my initial phase will support me. So initial phase will support me in this particular way. The way you can able to see this KO procedure is what I need to select it. KO procedure is nothing but direct generations of an initial effective stresses. Initial effective stresses, pore pressures, and state parameters. So, but the vehicles, the values that is generating it over here is not a guaranteed one, but it is mandatory that we have to do this one. Okay. And remember the sigma m weight and pore pressure calculations is something like what is the water level that you are mentioning it. So if you just select it as a pneumatic level, then it is going to select this as a, yeah, and it is going to understand this is a groundwater level. But if you have changed anything apart from the groundwater level, then you have to go it as a steady state groundwater flow. So now this is only the groundwater level. Thermal calculation type. Do you include any thermal calculations in this? If no, just put it as ignore temperature. But if you yes, put earth gradient. Earth gradient is something like when you go inside depth. I mean, at the top level of a surface, the temperature is a one thing. And as you go deeper and deeper and deeper and deeper, it is getting cooled, right? So I just need to change the temperature also, or if it is getting heat in some cases also that you need to put those particular values. So for those particular conditions, you can use earth gradient. Or if it is a steady state thermal flow where you are maintaining, you want to maintain the entire soil as a constant temperature of 30 degrees centigrade or 40 degrees centigrade, that is also possible. But right now, I'm not considering any temperatures over there and just give, okay, remaining things on the all, I'll come back to you one by one. For this initial phase, you just remember only one thing. So the initial phase is the one that it is going to be calculated when there is a no constructions. What is the pore pressures it is acting on this particular soil? Now, make this particular habit. Once you're done with this in this, try to calculate this, then it will show you that select the nodes and stress points. These are all like a warnings. If you see, these are all like a warnings. Don't worry about the warnings. If it is an error, then only you have to consider it. But if you are interested, we'll also come back to this, what is an each and every step, but not now. For the time being, you just click on this, ignore feedback and calculate it. Then your calculations is done. So when the moment then you will just go for the calculate, now you see that the reason green tick mark it is coming. So now the calculation is done for this. Now, after calculating this one, you have to go and add a new phase. So in the phase explorer, there is a button called as an add phase. If you click on this, this will help you to add these particular phases. Now, in this particular phase one, this is the phase one. If you double click on this particular phase one, it allows you to do all the changes that whatever it needed it. So ID is like phase one. And if you would like to rename this particular thing, you can rename them all the time, no issues. And the input for this particular phase is the before calculations. That is an initial phase. And what I'm going to do calculate it here, I'm going to do only the static calculations. That is nothing but your plastic calculations, we can say. And if you are just trying to do some kind of a consolidations, then you can have an option to select consolidations or safety. So, but right now I'm just doing a plastic calculations. It is an elastoplastic drained or an undrained analysis consideration, not consolidation is not considered over here. So it will just calculate the elastoplastic drained and undrained analysis. That's it. Not more than that. That is, it's a simple calculations. Again, the stage, it is just a stage construction. And again, remember that sigma m weight and sigma m stage, all these two values always to be a 1. This is because of the Newton-Raphson method. It is following it. I will come back to you. I have a separate slide for that. I will show that and I'll explain you that as well. And I'm just trying to solve with my groundwater pressure only. I mean groundwater level, and just give OK. The remaining and all you can just go for the default and just give OK. After giving OK, now I need to activate the line loads on this. That is, I have a soil. Over that, I need to put a foundation. Over that, I need to put a building, right? In general. But here I'm solving a rigid foundation problem. So that's why I don't have a foundation. I don't have a building. So whatever the load it is coming, directly it is coming onto my soil. So that's why I will directly activate that particular line load over there. So now the line load, it's got activated. If you click on this in the selection explorer, it will helps you to edit the values of your line load. Now, let's say that the line load, it is in the negative y directions as per the image also you can able to understand. I'm just keeping it something like a line load of 100 kilonewton per meter squares of a load that I'm just trying to keep it on this particular soil. Now, the moment when you just click on this calculate button, now it's going to calculate this. Please be remember this graph. And please be remember the values over there. Okay. That's a good example that we got it. Now it's got failed. Why it's got failed, that also we can analyze it. And you just go for this particular rigid foundations. The load advancement procedure got failed and error code of like a 103. So the loading of this particular thing that is got failed, that is only the reason that you can able to see this particular thing as it is got failed it over there. Okay. And why this is happening and how I need to control this. Yeah. Load advancement failure is something like where the amount that you are feeding it, the load amount that you are feeding it is really a too high actually. To handle this, it's really a too high. Now, let's make this as like a 10 kilonewton per meter square that I'm trying to solve it. Now solve this particular example. Calculate all the phases. Now see this one as the load advancement. Now try to remember this, guys. The load advancement failure, error code 103, if any time that you are getting it, the amount of the input that you are giving is too high to solve this particular equations. So try to break down the particular load into a multiple stages. Now, you go for this particular rigid foundation, I'm adding this another way. And now this particular load, again, I'm just putting, previously I put 10 and plus 20 I'm keeping it. So that means totally 30 kilonewtons that I'm just keeping, kilonewton per meter square that I'm keeping it now. This is how, see, now for 30 kilonewtons it has been solved. Now, if you just wanted to go for another 20 also, that's also fine. So now you just calculate this. So this is how actually you can see these particular things and all, where exactly it is failing. You can just check out this particular number, how it is reaching. Sigma n stage. If it is reaches to 1, your problem is done. Okay. So this is how now it is like 20, 20, 40 plus 10, 50. So totally 50 kilonewton per meter squares of a load, it has been achieved it there. Now, the moment that when you click on this phase 3, now if you just go to the reached values here, to the reached values. So you can able to see this particular things that the load that you are applying it, and you would like to see the displacement it is happening it. If you would like to see the displacements or the deviation it is happening it, so click on view results. Click on view results and put control 2. Now this is how you can able to see this one. The deformations it is happening at phase 3 is something like 3.4 10 to the power of minus 3 meters. That is 0.003 meters of displacement it is happening at element 286 at node 4. Of that element number 286, it is happening at node 4. If you would like to know, go to the mesh and click on this element numbers. So this is where actually 286, this is the 286 is your element at that particular node 4, it is going to be happening on this way. So this is how actually it is happening it. I've just given you a very glance about this. By this time, if you could have gone through that particular PDF, what I have suggested it already, you might have understand this, but don't worry. Try to practice it as by looking into this video tomorrow. End up with any errors, that is also fine. End up with some results, that is also fine. But don't worry about the accuracy of your results at this point of time. Try to practice this and make familiar the options that which are available and try to analyze yourself. And I'm expecting a few questions from you guys actually, because wantedly at the middle, I just skipped some particular pointers where I'm expecting these particular pointers to come in from your side. So I'm just waiting for those particular pointers and we will be continuing our session again on Tuesday. So please be practice this for tomorrow and get back to me for those particular pointers, or you can record it in the groups also. I mean, in our board, that is also fine for me. With this, I would like to take a pause. If you have any questions that we can